Hey everyone, it's Mr. Anderson. Today we're going to be looking at section 4.2.5 from our CPM ebook, and our goal today is going to be to further investigate some methods for solving systems of equations and wrap up chapter 4. And the big question that we're trying to answer today is, what is the best method? So today we're going to kind of rehearse all of our methods. We're going to talk about how each one's possible, and we're also going to talk about when each one might surface as the easiest method and really offer the best opportunity for solving. And we'll start with with problem 4-77 here. And it is a word problem, and it does incorporate what I think is one of the most difficult skills of this particular unit, which is having students write the equations, write the system. And so we'll start with that. We'll rehearse that, right? But first, let's make sure we read and we understand. Erica works at a soda bottling factory. As bottles pass on her conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks a bottle before she can cap it. She gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents from her pay for each bottle she breaks. Erica's having a bad morning. 15 bottles have come her way, but she has been breaking some and has only earned 6 cents so far today. How many bottles has Erica capped, and how many has she broken? Okay, well, in the question lies the things that we're going to be solving for, right? She's got capped bottles and broken bottles. So I went ahead before I started the video and I let X be my capped bottles and Y be my broken bottles. The let statements, are very important. It lets me know what I'm solving for. It lets my reader know what I'm solving for. Very, very important step. And you might be tempted to use C and B here, right, for capped and broken, and that's fine. That's going to work. I went ahead and used X and Y, and the reason I did that was simply for the fact that we could check with some graphing, right? I'm going to remind you how to do that today. Okay, and let's go ahead and let's see what it is we know. We know, and I'll do some highlighting of some information here. I'm going to go to what's easiest for me first. If you went somewhere else first, you didn't necessarily do it wrong. I just went for what's easiest for me. All right, so far, 15 bottles have come her way. And she's been breaking some, right? So we know that there are some broken. We know that there are some capped. So the easiest thing for me is going to be to take the number of capped bottles and the number of broken bottles, and say, hey, those things got a total 15, right? Because she's had 15 bottles pass her, right? Okay, so there's my first equation, and that is a pretty gosh darn easy one to deal with. In fact, I'm going to like that one we have to solve here in a second. All right, the other information is kind of tied up between both paragraphs, and I'll try to highlight this and show you where it is. She gets paid 4 cents for each bottle she caps, and her boss deducts 2 cents for each bottle she breaks. And so far today, she has only earned 6 cents. Since all those things have the exact same unit on them, that's a good indicator that I know that they're going to be going together. So what I'm going to go ahead and do here is I'm going to take all that information, I'm going to assemble it. I know she gets 4 cents for each capped bottle. That's a rate, so I'm going to multiply it by the number of bottles she caps. For me, that's X. Now, normally we'd add to it, but because her pay for broken bottles is deducted, I'm not adding here. I'm going to be subtracting, right? Deduct, remember, is that word that means we're taking away, okay? And her boss is going to deduct 2 cents for each broken bottle. Now, finally, we're given some information in that second paragraph there that says she has earned a total of 6 cents. Okay, check out what we have here in part A. We've got 2 equations, each with 2 variables, and now because we have that set up, we can go ahead and do some solving. That's exactly what B asked me to do. It says solve the system using 2 different methods, substitution and elimination. Demonstrate that each method gives the same answer. Now we're getting pretty good at this. So I'm going to go ahead and I'm going to use substitution first, and I'm going to do it maybe a little quicker than maybe I would in some other videos. All right, I'm going to write that first oops, sorry about that. I'm going to write that first equation second and the second equation first. I'll show you why. All right, so it looks like this, and I'm allowed to kind of mix these things up. Right, and this is because this is going to give me a little bit of space to do some solving for y here. Okay, and here comes my substitution. Because now what I can do is I can take this and I can sub it into the other equation. That's so important. I can sub it into the other equation for x. Okay? I apologize. I think I said a moment ago, I think I said solving for y. I was solving for x. Sorry about that. I was subtracting y, solving for x. Okay? But now I can rewrite that, and I can say 4 times x minus 2y equals 6. And here is where I can sub in what I know x is. Okay, I know x is 15 minus y. And some reasonably simple math here. 4 times 15 is 60. 4 times y is 4y. Minus 2y equals 6. Okay, and now I've got to go this direction here, so you're going to have to follow my work. Okay, combine my like terms. I've got 60 minus 6y equals 6. And now I've got to get rid of the 60, move that to the other side, so I'll subtract 60 from both sides. Okay, and then I've got negative 6y equals 6 minus 60 is negative 54, and then we'll divide both sides by 6. And I get y is equal to 9. Okay, that means Erica broke 9 bottles. Now, this is actually a pretty convenient substitution back in to this other equation. Okay, I'm going to take my modified form, this whole thing, and I'm going to just kind of send it over here, and I'm going to say x equals 15 minus y, right? That's what I had, 15 minus y, but now I know what y is, folks. Y has got to be 9, and here's how that substitution works out. I've got x is 6 and y is 9. Now check that out. That means she capped 6 bottles, she broke 9 bottles. And if this was a test, I'd like to see you guys only solve this one way. I'm going to go through both methods here in a second. But then make it reasonable. Make it understandable, right? Give me a sentence that says and correctly explains that you know exactly what's going on. So ladies and gents, x is 6, y is 9. I'm going to do the exact same thing, but now I'm going to use my my elimination method. And elimination actually is not too bad. I'm going to just kind of borrow what I have here. And this is the convenient piece with using this notability program. I can select it, right? My system. I can copy it. Then I can go over here and I can paste it. Okay, and the pasting works really, really well for the purposes of elimination. Now check this out, because eliminating is going to give me that same solution. We know x is 6 and we know y is 9, but I got to do something first, and I'm going to take this entire second equation and I'm going to double it. Now why am I doubling it? Well, here we go. I can recognize that right here I've got a negative 2. This is only a 1, but if I double it, it'll be a 2. So a negative 2 and a positive 2 is going to make opposites, okay? I'm just going to rewrite that first equation. 4x minus 2y equals 6. I didn't do anything to it. I just rewrote it. But now I'm going to double everything in that second equation. 2x plus 2y equals, and don't forget to double the 15, right? Now we've got those opposites, and here's where that column addition comes in. Pretty gosh darn handy. 2x and 4x, that makes 6x. The 2y and negative 2y cancel, and we get 36 there, right? Because 6 and 30 makes 36. All right, then we just divide everything by 6, and we get x is equal to 6. Ding, 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 ding. That's what we got over on the other side as well. We knew that was coming. Now I get to sub in to either one of those equations. And I'm going to use this bottom one because I don't have any coefficients there. It was x plus y equals 15. Well, I know x is 6. And then I can just go ahead and subtract 6 from both sides. And again, we get y is equal to 9. There you go, folks. Pretty easy and manageable way to do that. Which method do you like best? Which one was easiest? Okay? Right? Had to do a little bit of work to get that substitution method to work. Had to do a little bit of work to get that elimination method to work. All right? in this particular situation, I'm not convinced that there's a method that's better than one method better than the other. All right, but one thing I am going to remind you of, and this is why I wrote my let statements in X and Y versus C and B, is the graphing method. Remember, we've got this graphing tool, and that graphing tool is, of course, Desmos.com. And once I have those equations written accurately, I can just go to Desmos. I can type them in exactly like I see them. 4x minus 2y equals, what do we have, 6. I can go to my second equation, and then what did I have there? X plus y equals 15. Right? And I always recommend that you guys do this, right? And then you're just looking for that point of intersection. Okay, and there it is. There's that point, and that conveniently matches exactly what we had over here, right? Okay, it's not a bad method to check. However, when we're assessing, when you got to show your work, remember, we're looking for that algebraic solution, okay? Ladies and gents, the last question that I've got that I'm going to go over with you guys is a couple of these problems here in 4-78 where we've got some systems. We're not actually going to do the solving, right? You might want to do some of these things as practice, but I'm not going to do the solving. I'm just going to talk about what method I would use if I had to solve these, okay? And I'm going to use like the abbreviation sub and elim for substitution and elimination. I'm not really going to focus on the equal values method, and I'll explain, well, I guess I will, but let's start with A, right? A is one, let's pick a different color here. I like purple. A is one that I would use substitution for. And you're going, Anderson, why in the heck would you use substitution on A? And I would say, this is the dead giveaway. I've already got X by itself. That means it's a freebie to sub 4 minus 2y into the second equation for X. Then I got one equation, one variable. Okay, so A is a definite substitution for me. Check out B. Check out B right here. I've got 3x plus y equals 1, 4x plus y equals 2. They're set up. Everything is stacked. I don't have opposites, but I could multiply that bottom equation by -1. And when I do that, I'll have opposites. That means that's an elimination problem for me, okay? I could take this entire thing down here, multiply everything by -1, or just effectively switch that sign on every single item in there, and now I'm going to get those y's to cancel out, okay? That's an elimination problem. And of course, if you do that, this becomes a modified equation. You don't necessarily need that first one unless you need to do some graphing or some solving, okay? All right, let me come back to C here in just a second. How about D? What's your prediction? All right, if you want to, pause the video, but I'm going to remind you that in D, X is by itself, and what does that mean? That means this should be a substitution problem. I would substitute here. I could take 2y plus 5. I could plug it into that top equation for X. Okay, let's back up. Let's check out C. All right, you've heard me talk about this before. We've got X equals -5y plus 2. You've got X equals 3y minus 2. I think a lot of us call this substitution, right? Because we've got X by itself here, X by itself here. Remember, we're talking about this out of a CPM textbook, and CPM has this equal values method that they push, but this is effectively just a substitution problem, right? You would essentially, to solve this guy here, you would just set that right-hand side of that top equation equal to the right-hand side of the bottom equation, and that's why they're equal values. All right, time for one more, folks. Time for one more. Let's go ahead and let's tackle something like E would be equal values, right? But let's tackle something like F, okay? F is going to be a good one. I got both of these things in standard form again. And what does that mean? That means X and Y are on the same side, okay? But again, I don't have opposites. So what I could do, and this might actually be an interesting one for you to try, what I could do is I could multiply the top or bottom equation by something to give myself an opposite. I predict that if I multiply this bottom one by 2 and rewrite it, I'm going to have 6x minus 2y equals negative, oh man, I think that's going to be -76. Okay? But then if I get rid of this, what's going to happen when I go to eliminate? Check that out. See if you can come up with that. Okay? Because something interesting might happen, a good reminder. All right, after you check that, ladies and gents, I'm going to encourage you to put some of these things into practice on your own. And we've got a couple of preview questions here. 81 to 83. There's just 3 of them. One of them is going to have you right in your own system. Ladies and gentlemen, thanks for watching. Have a great day.